All right, the last example is example 4. So we have objects accelerating on an inclined plane. So we're going to examine the diagram of two masses connected by a strong taut string over a frictionless pulley, where mass 1 is 7.4 kilograms. On an inclined plane with theta being 24 degrees, and mass 2 is 5.9 kilograms. Our coefficient of static friction is 0.35, and our coefficient of kinetic friction is 0.28. The first thing we need to know, or the first thing we need to do, is show that the masses will accelerate. So for A, we need to show that acceleration is not equal to 0. The first thing I'm going to do is draw my diagrams. I have the mass of 1, which is 7.4 kilograms. The force of tension is pulling it up the inclined plane. The force of friction is working against it. The normal force is going perpendicular to the mass. The force of gravity is pulling it down. And to make life easier, we're going to break this into x and y components, because our y components will run even with the force of tension and the force of friction. Our x components will. Our y components will run with the force that's normal. So I can say the force of gravity 1 is equal to mass times gravity. So it's equal to 7,252 newtons. The force of G1y is equal to the force of G1 cosine of theta. That's also equal to the normal force. And the force of G1x is equal to the force of G sine of theta. For my second diagram, I have a mass that's 5.9 kilograms. The force of gravity is pulling down on it. That's equal to mass 2 times gravity. So the force of gravity 2 is equal to 57.8 newtons. I have the force of tension pulling up. So for acceleration not to be equal to 0, the force of gravity 2 has to be greater than this force of tension. So if that is true, then mass 2 will accelerate. So we need to check if the force of tension is greater than the force of friction plus the force of gravity 1, because it's got to overcome this force of friction in order to move. All right, so the first thing I need to figure out is, what is this force of friction plus the force of gravity 1? So the force of friction plus the force of G1. My force of friction is going to be the coefficient of static friction normal force plus m1g sine of theta. We're looking on this x-axis right here. Force of friction, this force of G1. My normal force over here is equal to the force of G1y. So I can say the coefficient of static friction, mass 1, gravity, cosine theta, plus mass 1, gravity, sine theta. Now all I need to do is plug in what I know. The coefficient of static friction was a given. It's 0.35. So I have 0.35 times 7.4 kilograms for my mass 1 times 9.8 meters per second squared, cosine of theta, and it told me theta was 24, plus mass 1, 7.4 kilograms, times gravity, which is 9.8 meters per second squared, sine of theta, so sine of 24 degrees. All of that is going to come out to be 52.68 newtons. So F, the force of friction, or the frictional force, plus G1x is equal to 52.68 newtons. Okay? Now we need the force of tension. And we need this force of tension. So to figure out the force of tension 2, it's going to be equal to the force of gravity 2. The force of gravity 2 is 57.8 newtons. The force of tension 2 is going to be 57.8 newtons. So I have 57.8 newtons, and I have 52.68 newtons. So this is greater, so this is going to hold true, so the masses will accelerate. This one is going to accelerate down. I'm going to choose positive and negative to make that my life a little easier. This one's going to accelerate up. I'm going to choose positive and negative. Now we need to determine the acceleration of the two objects. Because the masses are accelerating, we're going to switch to the coefficient of kinetic friction. And I'm going to start out over here. So I'm on part B now. So I'm going to figure out the forces. Woo. I'm going to figure out the net forces in the x direction of M1. So I have M1. My force net in the x direction is equal to the force of tension plus the force of friction plus the force of G1x. The net force in the x direction of M1 is equal to mass 1 times acceleration equal to the force of tension. The force of friction is in that negative direction, so I can go ahead and say the negative coefficient of kinetic friction times the normal force. Force of G1x also in that negative direction. So I'm going to put minus the force of G1 sine of theta. I can break this down a little more. I can say mass 1 acceleration is equal to the force of tension minus the coefficient of kinetic friction. My normal force is Fg1 cosine theta. The force of G1 is mass 1 times gravity, so I'm going to put mass 1 gravity cosine theta minus, this is going to break down to mass 1 gravity sine of theta. I'm going to simplify this. Mass 1 acceleration is equal to the force of tension minus the mass 1 gravity times the coefficient of kinetic friction cosine theta plus sine theta. Mass 1 acceleration is equal to my force of tension is 57. Whoop, can't go there yet. I don't know that yet. I'm sorry. Let's go to mass 2. For mass 2, my net force is equal to the force of gravity 2 plus the force of tension. So the mass 2 acceleration is equal to mass 2 gravity minus the force of tension. I'm going to solve this for the force of tension. So the force of tension is going to be equal to mass 2 gravity minus mass 2 acceleration. I'm going to plug this in over here for the force of tension. Mass 2 gravity is 57.8 newtons. Minus, we don't know our acceleration yet. And this number we can figure out. Mass 1 gravity. So the force of gravity 1 is 7,252 newtons. The coefficient of kinetic friction is 0.28. Sorry, is 0.28. Cosine of 24 plus sine of 24, we're going to get 48.04663 newtons. I'm going to combine like terms. So I'm going to get mass 1 acceleration minus mass 2 acceleration is equal to 58 newtons minus 48.04663 newtons is 9.7734 newtons. I'm going to divide that by mass 1 minus mass 2. So acceleration is going to be equal to 0.07348 meters per second squared. Last but not least, we need to do part C. Part C wants to know the force of tension in the string, like all the part C's. So I'm going to go back up here to this force of tension problem. The force of tension equals mass 2 gravity minus mass 2 acceleration. The force of tension is equal to mass 2 gravity is 57.8 newtons. Mass 2 was 5.9 kilograms. Acceleration is 0.07348 meters per second squared. So my force of tension is equal to 53.48 newtons. When I get to this point, all I have to do is write my therefore statement. My therefore statement is going to say the masses will accelerate at a rate of 0.73 meters per second squared. That's our answer to part B. Up the plane and down respectively. And the force of tension in the string is 53 newtons.